Okay, well, we're starting our unit on thermodynamics, so the first thing we're going to do is talk about some terms that you need to know. Thermodynamics deals with the energy of chemical reactions and all the different forms the energy can take. So that's where we're going to begin. If you remember back to middle school, there are two types of energy, potential energy and kinetic energy. Potential energy, in general, gets defined as stored energy, where kinetic energy is energy of motion. In terms of chemistry, potential energy is the energy stored in chemical bonds. So if we look at this diagram over here, this gives us an idea of what's happening with potential energy. When a bond forms between two H atoms, there is a force of attraction between the two atoms, and there's also forces of repulsion. So the two nuclei will repel each other. The electrons from the two atoms will repel each other, but the electrons from one atom are attracted to the nucleus from the other atom. So if these two atoms are too far apart, then what happens is that there's no force of attraction between them. As they get closer together, there starts to be a force of attraction between them, and that force of attraction is governed by something called Coulomb's law. So Coulomb's law says the force of attraction between oppositely charged particles is directly proportional to the size of the charge and inversely proportional to the distance. So the closer these two get together, the more force of attraction there are. At some point, there's an optimal amount of force of attraction, and a bond is formed. If the atoms get too close together, then the forces of repulsion overcome the force of attraction, and those two atoms are pushed apart. So when the bond forms, and we have that optimal relationship between forces of attraction and forces of repulsion, energy is released. So for the hydrogen atom, two hydrogen atoms forming a bond, the amount of energy released when that bond is formed is 436 kilojoules per mole. So to break the bond between these two, I must add 436 kilojoules per mole. So that energy is stored in the bond. So that's the potential energy. The other type of energy, kinetic energy, energy of motion, that comes from the atoms moving around. And remember, temperature is a measure of the average kinetic energy of the particles. Okay, other terms. Thermochemistry is the study of heat changes in chemical reactions. So that's what we're going to be studying. And then the next the next three actually are really key. System and surroundings. Let's deal with those first. The system is what is being studied. And the surroundings are literally the rest of the universe. So if we're studying a chemical reaction, the system is composed only of the molecules, ions, atoms that are actually reacting. So if we're reacting two solutions, the only thing that's reacting within those solutions are the positive and negative ions. So the water is not part of the reaction. So the water that is holding the ions is actually part of the surroundings. The cup or beaker that is holding the water is part of the surroundings. The thermometer that's taking the temperature is part of the surroundings. The classroom is part of the surroundings. The building is part of the surroundings. The earth is part of the surroundings. The solar system is part of the surroundings. You get the idea. The system is very small and very defined. The surroundings is everything else. Now this other term, state function. A state function is a measurement that is independent of pathway. So what that means is that, for example, you're sitting in a room right now. That room has probably not been at a constant temperature. Sometimes the temperature has been higher in that room, and sometimes the temperature has been lower in that room. But it doesn't matter what any previous temperature of that room was to measure the temperature of the room at this moment in time. So the temperature of the room at this moment in time is independent of any other temperature that room might ever have been. That would be a state function. So things like temperature is a state function, mass is a state function, volume is a state function. It is what it is. It doesn't matter how much was there before or how much might be there later. Okay, so when we start looking at thermodynamics and thermochemistry, the first thing we're going to be dealing a lot with is heat. The symbol for heat is lowercase q, and that talks about thermal energy. So heat cannot be measured directly. We can measure heat through transfer, and we measure heat by taking temperature. Temperature and heat are not the same thing. Temperature just gives us a measure of the average kinetic energy of the molecules, and the more kinetic energy they have, the higher the temperature is and the more heat they have. So whenever we take two objects and put them together, if they are not at the same temperature, they will come to something called thermal equilibrium. The temperature of the hotter object will cool down, and the temperature of the colder object will warm up until both objects are at the same temperature. And that temperature is, once we get to that temperature, that would be thermal equilibrium. Sorry about that. Work. Work is application of force over distance. That's a physics term. We're not going to worry too much about work in chemistry. We're going to worry mostly about heat, as you'll see here in a minute. Okay, heat and work are the two elements that give us the first law of thermodynamics. The first law of thermodynamics is energy can be neither created or destroyed. And you've heard that before. That's kind of the chemistry version of the first law of thermodynamics. The actual definition of the first law of thermodynamics is the change in energy of a system depends on the heat flow in or out of the system and the work done on the system or the work done by the system. So again, if you take physics, you'll run into that equation again, but for right now, all you need to know is that's the mathematical definition of the first law of thermodynamics. In thermodynamics, we have a sign convention. Whenever energy flows into a system, we give that number a positive sign, no matter what type of energy that is. When energy flows out of the system, we give the measure of that amount of energy a negative sign. And you're familiar with this with endothermic and exothermic reactions, and that's where we're going to see positive and negative. Positive is endothermic, which means heat is flowing into the system, so it feels colder. In terms of system and surroundings, when heat flow is positive, heat flows from the surroundings into the system. When energy flows out of the system, the sign is negative. In chemistry, that's an exothermic reaction. Heat is given off. Heat goes from the system to the surroundings. And those are all the terms you need to know right now for thermodynamics.